Today I'm going to build the Stealth Press 1S from Iconic Fab, a 3D printable heatset insert press available on printables.com. I've started adding heatset inserts into my printed parts to add some professional flair to my projects. But I've been doing it by hand. I want to see if adding a heatset insert press to my workshop will help improve the quality of my printed parts or just become another fun looking toy gathering dust on the corner of my desk. So, heatset inserts, sometimes called threaded inserts, are these tiny brass pieces with screw threads on the inside and ridges on the outside. They are designed to be inserted into plastic parts by heating up the metal with a soldering iron and pressing it into the plastic. The melted plastic will then cool and harden around the ridges to create a tight bond. This can be used to add screw threads to your 3D printed parts. Alternatives include designing your parts with slots for nuts. This can be challenging as the slots need to be just right. Too loose and the nut will fall out. Too tight and the nut won't fit at all. This can be even more complicated as not all printers print the same. In addition to adjusting your design's tolerances, you may also need to tweak your print settings in your slicer to print parts with just the right fit. You could also design your screw threads directly into your part. Unfortunately, due to high tolerances and large layer heights, this will only work for large screw diameters. This gives you the simplicity of not requiring any additional hardware, however, it will be too bulky for many situations. This technique is often used for screw top containers where the large diameter is a necessity. A third option is to use self-tapping screws and screw directly into the plastic. This, in my opinion, is the easiest option. It doesn't take a lot of design work, and the only hardware that you need are the screws. Unfortunately, by screwing directly into the plastic, you will wear the plastic down quickly. If this is a one and done situation where you just need to fasten two parts together, this works quite well. If, however, this is for a part that needs to be removed frequently, such as a battery compartment, the screws will eventually wear down the plastic and strip the threads to the point where the screws will no longer hold. The only fix is to reprint the part. Heatset inserts may be the best option as they can be easily designed for, and they will give your printed parts the accuracy and durability of machined threads. The only downside is that you will need a soldering iron handy, preferably one with a tip designed for heatset inserts. When I add heatset inserts into my parts, I add them by hand. It can be a bit of a headache. You have to gently press the insert into the part while keeping the soldering iron as level as possible. As the plastic starts to liquefy, the opportunities for the insert to shift and become misaligned increases. Now, I don't usually work with my hands, so it can sometimes take me a few tries to get it just right. This is why I want to build a heatset insert press. There are many 3D printable heatset insert presses available online. I chose to make this Stealth Press 1S as it seemed to be easy to make with few non-printed parts and was one of the most downloaded designs. Now, this isn't going to be a full build video or assembly guide. Iconic Fab already did an excellent assembly video, and a link is provided in the description. This video will be a third-party review of the Stealth Press 1S design and heatset insert presses in general. To give a proper review, I first must build the Stealth Press for myself. I started by gathering the materials. Most are common parts, many of them I already had, like some M3 screws, ball bearings, and a soldering iron. The most expensive part was the linear rail. I also chose to use the generic retractable device to save some money. I then printed all the parts using a similar black and red color scheme. I printed everything in PLA as that is what I had on hand. It is recommended to print certain critical parts such as the arm in ABS or ASA as they are more resistant to temperature changes. So we will just have to see how badly PLA is going to warp. So I made a mistake when buying the heatset inserts for this build. The bill of materials lists the inserts as M3 by 5 by 4. That is an outer diameter of 5mm and a length of 4mm. Some parts on Amazon list M3 by 5 by 4 as an outer diameter of 4mm and a length of 5mm. And I bought the wrong ones. They fit in the holes but are too narrow to be soldered in place. I could have just used super glue, but I decided to reorder the correct size instead. Next time, I have to remember to look at the description, not the shorthand. With that mistake fixed, I'm ready to continue with the assembly. As I am putting this together, I do find it a little ironic that I'm manually using Heatset inserts to build a tool to help with Heatset inserts. But maybe this experience will help me appreciate the tool a little bit more when it is finished. So I managed to put it together with only a few screws that were misaligned and wouldn't go in. But it probably has more screws than it needs, and it still seems really stable even with a few screws missing. The hardest part with the assembly were the ball bearings at the top. You have to squeeze 2 ball bearings and 2 washers together in such a tight space. And you have to keep them aligned for a bolt to be able to pass through their center. That took me a few tries, and I had to get the tweezers out to help. And there you have it, one Stealth Press 1S ready to go. Let's test it out. I'm going to use the centerpiece of the Stealth Press as my test, since it has 6 holes on one side designed for Heatset inserts. 3 of the holes are going to be done manually, and the other 3 using the Stealth Press. This will be an easy way to compare the results. The 3 on this side were done manually, while the other 3 were done on the Stealth Press. All 6 Heatset inserts went in easily and are probably aligned well enough to work. However, the ones done by the Stealth Press do look better. 2 of the 3 inserts that were done manually are slightly off center, causing some of the melted plastic to pull up more on one side than the other. All the ones done by the Stealth Press look perfectly aligned. So, was this worth the effort? Will I use it in future projects? I think so. Having a Heatset insert press in my workshop definitely does increase the quality of my parts, and the Stealth Press is a good looking piece of equipment. I do, however, have a few comments on the Stealth Press 1S design. First off, I'm not a fan of how much space it takes up. With the retractable device sticking out the back, nothing can be placed directly behind it. If the device was rotated 90 degrees, it could sit flush against the back of the Stealth Press. One of the major pain points in setting up this design was installing the bearings. It uses 2 flange bearings that have to be pressed together using 2 washers so that the cables don't slip off the bearings. Getting those pieces lined up took some time and was rather frustrating. Alternatively, the design could have used V-groove bearings. They are essentially a bearing with 2 flanges. This means that you would only need 1 bearing and the washers would be optional. One final note is that the linear rail extends all the way to the base. However, the arm will never need to extend that far since it will be holding onto a soldering iron. I might have been able to get away with buying a shorter linear rail and save some money. A nice thing about this design is that it's publicly available on printables.com, so you are free to create your own mods and share them with others. I would like to thank Iconic Fab for making and releasing this design. I had a lot of fun building this, and it will make a great addition to my workshop. I hope you found this video helpful, and if you have any questions or would like to see me review some other design, please leave a comment. If you like this video, please give me a like, and don't forget to subscribe for future content. Thanks for watching.